It's important to remember, yet often overlooked, that primates have come an incredibly long way over the course of prehistory. It has taken many convoluted steps and trials and errors of evolution to get to where we are today. Our story can in fact be traced back billions of years to when the first single-celled organisms drifted through the earliest oceans, when life first evolved. But the story of the primates, the group of mammals that includes us, begins much later. This is that story, a tour spanning 65 million years. Through some of the most unlikely circumstances, our ancestors and relatives have survived. While many species of primate have been lost to the fossil record, they represent one of the most diverse groups of mammals alive today. With our own species included, there exist over 300 distinct species of primate in the forests, grasslands, mountains, swamps, and even cities in the modern day, all of which are monuments to the success of this order of mammals' epic story. Join us as we explore the story of the primates, from their humble beginnings as nearly unrecognizable forest dwellers to the spectacular hominids of the mammoth steppe. We will stop at several points throughout the Cenozoic era along the way, examining key species of primate that sit on the family tree on the path to us. Sit back and relax as we explore the lives and deaths of our earliest primate ancestors. Primates have not always been here. Mammals, the class of animal of which we are a part of, have in fact persisted in their true forms for over 200 million years, 140 of which were millennia void of any true primates. The story of the mammals is one that goes back millions of years prior to this, through the deep time of the Paleozoic. But we will begin this journey here, in the expansive primal forests of the Mesozoic era. The mammals rose into being from a group of animals known as synapsids, who in turn were part of a larger group known as therapsids. The synapsids would eventually go on, throughout the Triassic, the earliest period of the Mesozoic, to diversify into a wide range of shapes and sizes. From dog-like carnivores to hippo-like herbivores, wallowing in the waterways of vast floodplains. Many synapsids, having evolved from reptiles, still resembled their ancestors, but changes were appearing steadily. Attachments in their jawbones were beginning to allow the evolution of strong jaw muscles, and in some instances, it is thought that certain genera were covered in fine fur-like layers. The first true mammal, Morganucodon, is thought to have appeared on the fossil record around 205 million years ago. It resembled a modern-day tree shrew, with a long snout and warm covering of fur. It would have had no way of knowing, but Morganucodon was in these dense forests of the early Jurassic, laying the foundation for all the mammals you know today, from the smallest mice to the largest whales. The descendants of Morganucodon would go on to populate the woodlands and jungles of the remainder of the Mesozoic, living in the proverbial and literal shadows of the most famous prehistoric animals ever, the dinosaurs. The mammals that followed Morganucodon throughout the Mesozoic, while diverse in form, would only grow to a maximum size of just over a meter. The largest of these mammals, dog-like carnivores such as Rapanomamus, may have even fed on young dinosaurs given the chance. Amongst these forests evolved otter-like water dwellers, tree climbers similar to shrews and squirrels, rodent-like burrowers, and small agile carnivores, many of which may have resembled modern-day badgers or wolverines, It is from some of these tree climbers that the first transitional primate ancestors were able to evolve, although the first true primates didn't appear on the scene until after the dinosaurs had gone extinct. The earliest known example of what could be considered a true primate, and therefore the earliest direct ancestor to human beings, is a small, peculiar tree-dwelling mammal called Purgatorius, named after the Purgatory Hills in Montana, where its fossils were discovered in the 1960s. Purgatorius would have, in life, resembled a squirrel, albeit one that was beginning to evolve longer, more slender legs to assist it with life in the treetops. The bones of Purgatorius have shown paleontologists the first similarities in the fossil record with living primates, details that can be observed in bones from the ankle and in the teeth. Purgatorius was a plesiadapiform, and members of this early group of primates are thought to have been widespread throughout the subtropical forests that existed across the globe in the wake of the extinction of the dinosaurs. Plesiadapiforms were in some instances superficially lemur-like and may have been the first mammals to replace their claws with fingernails. Some are thought to have possibly been able to glide on stretched-out folds of skin between their limbs, and many of the later genera show a much more distinct primate form than creatures such as Purgatorius. The closest living relatives to these plesiadapiforms, aside from modern primates, are the colugos, or flying lemurs, found in the rainforests of Southeast Asia. Amongst the genera of primates to exist throughout these early tropical forests of the Paleocene was Plesiadapis, which existed in both North America and Europe soon after Purgatorius evolved, around 58 million years ago. It is one of the most well-known of these early Paleocene primates, with almost the complete skeleton known. It is thought that these early species of primate first began to exhibit larger brains, relative to their body sizes, than other species of mammal that they shared their warm forest homes with. Elsewhere in the world, mammals were branching out into strange new forms, such as the pantodonts, a group of bulky herbivores, and the creodonts, a group of dog-like carnivores. In this world, our ancestors were still small, still to evolve with the capabilities of outwitting a predator or fighting back, and as a result, many of our primate predecessors would have fallen victim to new threats, such as mammalian carnivores, crocodilians, and early birds of prey. The primates had a long way to go before they were storming the plains of the Pleistocene, but they had to start somewhere. It was the Eocene that mammals, primates included, really began to diversify. Just like the giant herbivores, early whales, and airborne bats that appeared around the same time, our ancestors were beginning to take leaps of their own into lands unknown. From a branch of the plesiadapiforms of the Paleocene, evolved two new groups of primates, the Omomyids and the Adapids. Together, these primate groups are known as prosimians, a group whose members live on today in lemurs, lorises, and tarsiers. It was around this time, from roughly 54 million years ago to around 37 million years ago, that these primate groups began to branch out into new areas of the world. Previously unexplored reaches of North America, Europe, and now Asia too in the Omomyids case. These were the first primates to possess grasping hands, used perhaps for plucking food sources from branches and bushes. Throughout the course of the Eocene, both groups would go on to create an abundance of different descendant groups. some of which would succeed and go on to become the lemurs we know today, while some would get as far as the Miocene epoch, before ultimately going extinct. The first opposable digits are also known from animals of this time. Cantius, an adapted from North America and Europe, is thought to have been the first animal to evolve with an opposable digit, in this case a toe on its hind limbs. This is possibly indicative that Cantius may have been one of our own earliest ancestors, and not just to the lemurs and lorises of the modern day. This basic biological device would go on to form the basis of our very own thumbs, which you use to be able to press play on this video in some way, shape, or form. The Omomiids, on the other hand, only managed to spread their lineages out throughout the course of the earlier Cenozoic. Changes in the climate forced the descendants of these early primates into direct competition with monkeys and later apes, the latter of which were ultimately better adapted to the lifestyle that the Omomiid descendants were initially engineered to exploit. Just about all of the descendants of this once commonplace group had vanished by the end of the Oligocene epoch, the next chapter in our ancestor story. The Oligocene period represented a huge step forward in the diversification of mammals in general, not just the primates. But this is the time when some of our earliest primate ancestors began to come down from the trees, adapting to a lifestyle on the ground. Around this time, the first true monkeys began to appear, and one of the most important locations for the paleontologists who study them is Egypt, specifically the Fayum region of the country's western desert. Rocks belonging to the Kasser Saga and Jebel Qatrani formations have revealed to science the very first true monkeys, related to baboons, langurs, and mangabes of the modern day. From the Fayum region alone, in the various rock formations, existed the likes of Opidium, Catopithecus, Parapithecus, Oligopithecus, and Proteopithecus, just to name a few. And many of these remains are very well preserved indeed. The earliest known ancestor of all modern-day monkeys and apes known to science is Egyptopithecus, an animal that would have resembled a primitive version of the tree-dwelling monkeys of Africa and Asia. Roughly 90 centimeters in length from nose to tail, this monkey lived from around 38 million years ago to roughly 29 million years ago, and was thought to have moved on 4 legs through the trees, using grasping hands and feet to gain a stronghold on branches, something that has been determined through extensive studies on its hands, limbs, and muscles. It would have inhabited tropical forests, which were seasonally racked with torrential rain, where it fed on fruits and nuts in the canopies of trees. Characteristic of the early Cenozoic epochs was the persistence of tropical or subtropical forests across the globe, a far cry from how the world would have looked in the Pleistocene and the most recent stages of the era. Through studies on Egyptopithecus and its contemporary relatives, scientists have been able to determine that monkeys were becoming more and more comfortable walking on 4 legs through the trees, rather than scurrying or leaping through the branches like their prosimian ancestors. With the advent of adaptations in the hands and arms of these new and successful primates, monkeys were becoming more readily able to fend for themselves against the numerous threats that were evolving alongside them. Late surviving creodonts and early evolving carnivorans were popping up on the fossil record at the same time monkeys began to evolve, the latter of which would pose constant threats to our ancestors up until recent years. It was in the Oligocene, in fact, that primates found their way back to the Americas. having disappeared in North America due to climatic changes around 26 million years ago, and having never evolved in South America, there was a vacant ecological niche amongst arboreal frugivores and insectivores that an animal such as a monkey would be able to exploit. The fact that monkeys were able to survive in South America is one of evolution's greatest success stories. Today, monkeys are diverse and widespread across the continent, but the story of how they got there is perhaps even more astounding. 30 million years ago, just as the last primate genera from North America were starting to die out, South America, a continent completely disconnected from Africa, where monkeys had already evolved, saw for the first time monkeys. How did this happen? Across the Atlantic Ocean on the west coast of Africa, some time before they arrived in South America, a community of monkeys had gathered by the coast, perhaps to search for food or new territories with access to diverse habitats. Scanning the landscape for food, they happened across a huge batch of vegetation washed up by the beach. Running over, the monkeys were excited to find an abundance of fruit hanging from plants growing out of the mass of soil and vegetation and tucked in. The mass was large enough to sustain the whole troop for several weeks, and the monkeys were keen to stay. One evening, however, a huge storm blew across the western coast of Africa, dislodging much of the vegetation from the beachfront into a floating mass of plants and soil, with the monkeys on board. The monkeys, startled, quickly realized they had been blown out to sea, with little hope of swimming back to land and making it there in one piece. Food was available on this newly occupied raft, however, and the primates spent several days aboard it before finally hitting land. This land, however, was unlike the one they had come from. Strange new animals, marsupials and xenarthrans, stalked the land and ambled through the forests. The plant matter was different too, but these monkeys were adaptable. Water was available, as was shelter, and the monkeys could find safety from the carnivores below in the trees. This was South America. Fast forward 30 million years, and the ancestors of this very community can be seen in the forms of spider monkeys swinging through the trees on adapted tails, and little tamarins darting through the forest canopy in search of fruits and insects. The monkeys would thrive here. As incredible as this story is, through nothing but chance and natural selection, it is entirely true. This is not the only group of animals that would branch off from the African monkeys, however. It was around the late Oliogcene when the group of primates containing our very own species would appear, the apes. What are thought to be the very first apes appeared in what is now Tanzania around 25 million years ago. They diverged from monkeys due to changes in their environment, adapting to a life of living both on the ground and in the trees, using their long arms to pull them through the branches. Their faces would begin to resemble humans more closely than those of previous primates on the fossil record, and they would lose their tails entirely. They were no longer needed for balance for an animal that would eventually not need to walk on four legs through the trees anymore. These early apes would go on to form the basis of what was needed for all the modern groups of apes to evolve: gorillas, chimpanzees, bonobos, orangutans, gibbons, and of course humans. It was around the Miocene epoch, from 23 million years ago to roughly 5 million years ago, that the world's environment took a series of drastic changes. Mountain ranges rose up across the world, and more importantly, grasslands took a hold of many of the world's continents. the savannas of Africa, the pampas grasslands of South America, the prairies of North America, and the plains of Asia all cropped up around this time due to the diversification and widespread distribution of grass species. It was a direct result of these changes that ground-dwelling primates came into being. Monkeys and apes that were much better suited to feeding on these grasses or catching small creatures that lived within them. As the body plans of these primates evolved, so did their brains, and by the end of the Miocene and subsequent Pliocene epochs, the stage would be set for the world's first upright walking apes to evolve. Perhaps the most significant discovery to be made from the Miocene, in terms of human evolution, was that of a genus of ape named Proconsul, from regions that would one day become Kenya and Uganda. It is thought that the last common ancestor between human beings and all apes, gibbons included, which are not considered to be great apes, may have been Proconsul. Visually, Proconsul would have resembled an uncanny mix between Old World monkeys such as baboons and langurs and the apes such as chimpanzees. Its back would have been more flexible than those of apes who preceded it in order to more flexibly move around the branches of its forest home, but it would have still retained the quadrupedal walking style of earlier primates. While their hands were better adapted than their ancestors at grasping and manipulating their environment, they could not yet swing through the trees like modern apes do. Their arms were simply not powerful enough at this stage. Proconsul was not alone in the trees of the Miocene, however, and its family included a number of other genera, including Dendropithecus, Afropithecus, and Limnopithecus. Primates were expanding in Europe too. Pliopithecus and its closest relatives were known across the plains and forests of this northern continent, where modern wild primates are represented by just one species, the Barbary macaque. Once thought to be an ancestral form of the modern-day gibbons, it has now been determined that the Pliopithecids are actually unrelated to any other group of living primate. In Asia, primates were diversifying too. The Sawalik Hills, for example, which span Pakistan and the northern reaches of India, were known to harbor some of the most interesting and important specimens of prehistoric primate known yet, among which was Sivapithecus from the late Miocene. Sivapithecus represents the first split of the pongans, the subfamily which contains the orangutans, from the other apes of the Old World. While today orangutans are endemic to the Southeast Asian islands of Borneo and Sumatra, their ancestors were once much more widespread. Orangutan ancestors such as Koratpithecus are known from Thailand, Samburupithecus from Kenya, and even Gracopithecus, which was found in, of all places, Greece. Another one of the most famous fossil primates from the Miocene, this time discovered in a lignite mine in Italy in the 1950s, was Oreopithecus. With short teeth, an almost human-like face, and a possible tendency to walk upright, even if just temporarily, this was once thought to be a direct ancestor to Homo sapiens. It is thought to have been one of the first brachiators, that is, one of the first animals that was able to swing through the branches of trees using just its long, powerful arms. More recent studies have placed this ape within the Hominidae family, but it is no longer thought to have been one of our direct ancestors, having split off from earlier apes millennia earlier. Oreopithecus is thought to have inhabited swampy islands around this time, where it was isolated from many other species, and where evolution had the ability to take its course away from the pressures of the mainland. Eventually, Oreopithecus would come into contact with one of the most fearsome and impressive predators of the Miocene, the large saber-toothed cat Machaerodus. Changes in its environment such as these may have led to its eventual extinction. No apes like Oreopithecus exist today. By the time the Pliocene started, the world was looking very similar to the way it does in the modern day. Rainforests were commonplace around the tropics, around which were situated grasslands and mountains, deserts and scrubland, in just about the same locations we see them in today. All of the world's major habitats had been established, and there was therefore a much higher degree of familiarity in the fauna of many areas of the planet. Strangely, however, primates from this period of time are not well documented. Many apes and their lineages cannot be traced through to the Pleistocene, from the roughly 3 million years that spanned the Pliocene, and monkey remains are scattered and fragmentary at best. The best known and most significant fossils on the human line from the Pliocene is without a doubt Ardipithecus. Cropping up on the fossil record around the early Pliocene, from fossil sites discovered in the Afar region of Ethiopia, Ardipithecus was one of the first Australopithecines, one of our direct ancestors. While it was no expert at the habit, Ardipithecus could walk upright like you and me, even if just for a brief time. Its brain was still proportionally much smaller than later hominids who had succeeded, and it did not have the brain power to produce and use stone tools. That being said, it is not out of the question that Ardipithecus may have used simple tools, such as sticks and twigs, to coax insects out of their mounds, or rocks to break into nuts. Ardipithecus's arms would have been substantially longer than our own, and the animal was still well adapted to a life in the trees, a place where it would often have to retreat to avoid the dangerous mammalian predators that stalk the grasslands and forests in which it lived. It was through these humble beginnings that humanity was able to arise. In the forthcoming Pleistocene epoch, the world would be introduced to almost every other species of prehistoric man, from the Australopithecines to us. Now, the Pleistocene epoch has been covered in great detail on this channel before, but it is indeed the most important stretch of time to human evolution in this entire story. While the human story is known in intricate detail throughout this time, you may be surprised to learn that our knowledge of non-human primates from the Pleistocene is sparse and not well known at all. The only primates from the Pleistocene that are not directly related to us come from species later on in the epoch, and only from Africa and Asia. The likes of Paracolobus, Dinopithecus, and Rhinocolobus, for example. Perhaps the most famous non-human primate of all, from the bamboo forests of Southeast Asia, is Gigantopithecus, a gigantic relative of the modern orangutan, and likely the largest primate ever to live. This giant lived in family groups alongside other species of primate, including other hominids, where it ate fruit in the dense woodlands and bamboo thickets. It may even have gone extinct as a result of overhunting by Homo erectus, one of our earlier ancestors. The Pleistocene is best known as the time period that would end in the rise of man, however. Our earliest ancestors in these times, the Australopithecines, were well represented by the bipedal grassland dweller Australopithecus, which came from the Rift Valley in Africa. These apes were not stone tool users, but their hands were well suited to manipulating their environment, with fully developed opposable thumbs and long, powerful arms. Like Ardipithecus, they could likely use tools to coax insects out of mounds, but they were also likely to be able to throw objects to defend themselves against large, ferocious predators such as the big cat Dinofelis. Stones and sticks flying through the air would have likely been enough to put off even the hungriest of carnivores, who may have considered attacking a group of Australopithecus. Things get a lot more confusing in the Middle Pleistocene, often dubbed the muddle in the middle by anthropologists and paleontologists studying fossils from this time. After the rise of Homo habilis, a much more modern human stepped forward in relation to the more chimpanzee-like Australopithecus. Animals in the Homo genus had almost fully adapted to a life without the need to rely on trees for protection. The arms of the likes of Homo erectus had shrunk in relation to the sizes of their bodies, to the point where they were no longer needed to swing through the trees or climb up for safety. This is an evolutionary trait that coincided with the advent of technology, specifically stone tools. All members of the Homo genus are known to have used stone tools in some way, shape, or form to defend themselves against predators, cut up food, start fire, or even make art. Later hominids, from Homo erectus onwards, would go on to harness the use of fire in their lifestyles and hunting methods. With the use of controlled fire, early humans were able to reliably cook different types of food, bring down larger game animals in hunts, and defend themselves against the elements during winter. Towards the end of the Pleistocene, Homo neanderthalensis and Homo denisova, respectively known as the Neanderthals and Denisovans, would appear on the Mammoth Steppe, the world's largest continuous environment, characterized by rolling plains and extinct megafauna. These species would lead complex lives and were capable of creating art, controlled fire, and even speech. Their barrel-shaped bodies and tough exteriors would aid them in the rough, dangerous, and ultimately short lives they led, something majorly important in the brutal conditions of the Mammoth Steppe. They would soon be joined by Homo sapiens, us. It took us millions upon millions of years to get here, but soon enough, our very own species would be running through the tundras and plains of the Mammoth Steppe after giant deer, extinct bison species, and woolly mammoths. We would migrate to the Americas, where the first people to set foot in the north would encounter huge mastodons and ground sloths. Those in the south would meet armadillos the size of cars, and the famous saber-toothed cat Smilodon. Soon enough, Homo sapiens outcompeted the Neanderthals, interbreeding with them to the point where we essentially genetically consumed their species. We would migrate to every continent on Earth, from the scorching sands of North Africa to the frigid wastes of Antarctica. Our technologies would snowball to the point where we have full control over our environment and the species that live on it. And this is where our story ends. Greater pressures need to be placed on governments and corporations to save species, such as the apes, who are at risk of disappearing. To lose species living today is to lose a part of who we are. Each and every species alive today has followed lineages that began billions of years ago, at the same time as us. Distantly, we are all related and rely on one another to make this planet what it is.